All right, here's your second installment for the second method. It's called the equal values method. Basically, equal values method works really nicely if you are going to have a hard time graphing a particular set of equations. This again shows up when you got really big numbers. It also might be a valuable way to um, do a solution for a system of equations if you discover, oh man, I can't tell where on the graph that my 2 points are meeting. But anyway, again, I have two equations for you. We're going to go ahead and solve them using this uh, equal values method. First equation I have is y equals 3x plus 9,000. The second equation I have is 6x plus 3y equals negative 33,000. You see these big numbers would not make it super fun to graph. I mean, you could do it, you could scale it down maybe or something like that, but it just wouldn't be super easy to do. Whereas, again, using this equal values method might be a little bit easier. So, what we want to do, this one we can leave alone because basically what you're trying to do is just set both of these guys equal to x or equal to y. Now, what I'm seeing here is that since this is already set up as being equal to y, why not just go with that? Now, if one of these was x equals something and you wanted to set it up as, solve for the x for the other one, that is just as easy. But you can do it either way, x or y. But if something's given to you already, you might as well go for that one. So this one, we're going to want to set equal to y, very similar to what we did in the last video. Again, got to get y by itself, isolate the y. Um, and so basically, we want to remove 6x here, remove 6x there. What I end up with is 3y equals negative 6x minus 33,000. So from there, where I'm going to want to take that, again, divide off 3, and that's going to give me y equals negative 2x minus 11,000. So again, I could graph that, but it probably wouldn't be much fun because it's going to have to be either a really big graph or it's going to have to be somehow really modified in order to get it to work. Maybe I could, do each one as 1,000 or something like that, but probably not going to be super easy. I have to do a lot of thinking to make that happen. So now the idea is I've got a y here and I've got a y here. Well, those are the same thing. So if those are the same thing, what I can do is I can take this 3x plus 9,000 and set it equal to this negative 2x minus 11,000. And so I'm going to go 3x plus 9,000 equals negative 2x minus 11,000. And then I'm going to solve for x. So I'm going to solve for x. Again, I always move the smallest x. Negative 2x is smaller than 3x. So I'm going to add 2x over here. Again, build your wall if you prefer that. But that leaves me with no x over here. Okay. But whatever I do on this side, I have to do over here. So add 2x. That's going to give me 5x. Now my x is going to be over here. So let's get rid of my 9,000. So let's take away 9,000 here. Again, that leaves 0. That's gone. That's gone. And then I have to subtract 9,000 over here. Negative 11,000, take away another 9,000 is going to be negative 20,000. So 5x equals negative 20,000. If I divide by 5, I get x is negative 4,000. All right. Well, many of you might think, oh, I'm done. Well, not quite. Okay. Remember, this is a system of equations. So, what we have to have is we have to have an x and a y where both of these lines are going to meet. So, I do know right away that I'm talking about negative 4,000. Now I just have to figure out, well, what's my y to go along with that? And so let's go ahead and take this negative 4,000 and we can plug it back in here. We can plug it back in here. We can plug it back in here. Doesn't matter which one of those previous equations we plug into, we just have to plug it back into one. Well, because this one's already set up for y, I prefer to plug it back in there. So y equals 3 times negative 4,000 plus 9,000. And so 3 times negative 4,000 is negative 12,000 plus 9,000 means that y is going to be equal to negative 3,000. And so if I go over here, negative 3,000, this should be my answer. Okay. But again, as I mentioned before, we should always go back and we should check. We should see, does this actually work? Now, I could take this and plug it back in here, but that's what I just found. Okay, I just found this solution from this equation. So it's not a good idea to go back there. It's better to go back to this equation, plug both of these guys in there, because then we can see, oh, okay, I know it works here. I know it works here. Boom, I've got it. I know it works for both. Okay, so I'm going to take the 6, multiply it by, again, I'm going 6x plus 3y. Does that equal negative 33,000? Okay, so 6 times negative 4,000 plus 3 times negative 3,000. Does that equal negative 33,000? And so here is negative 24,000 plus negative 9,000. And guess what? That is negative 33,000. So that equals negative 33,000. I have a check, and I now know I am right. All right. So again, I hope this helps. I hope it gets you through method 2, your questions 3 and 4 in this packet. Um, if you run into problems, you know how to get a hold of me, TWyrick at auhsd.net. Have a great day.